Similar to what we were doing with the at-risk population, we're now asked to analyze the general population. We need to consider a patient in the general population. Of those with HIV, so we're given that the person is infected or that they have HIV, what percentage test positive? So again, since we know that they are infected with HIV, we want to know if they test positive. We have 57 patients that test positive in the grouping that I circled, out of a total of 60 patients that were infected. And from this, we end up getting a solution of 0.95, or 95%. And again, this goes back to the idea that the HIV tests are 95% accurate at detecting a true positive or a true negative. In addition to this, we are asked to find, of those who tested positive, what percent have HIV. So if we're told that they test positive, then they fit into this grouping of patients. And again, we want to know whether or not they, what the probability of them having HIV would be. So again, the probability of infected given tested positive. And again, since it says given tested positive, we circle the group that's tested positive in the general population. We can see that 57 of the patients tested positive and were actually infected, and that's out of a total of 1,054 patients that tested positive. And in dividing this, we end up getting a solution of 0.054 or 5.4%. So, given that you tested positive, or if you know someone that's tested positive and they're in the general population, there's actually a relatively low chance that they are infected. Suppose again that you're a doctor and a member of the general population comes in and tests positive for the disease. If you get this result, how can you use the table to actually determine the probability of the patient having the disease, and what should you tell them? So again, in the general population, we're given that information that the patient's in the general population. We want to figure out the probability that the patient is actually infected given that they tested positive. So that's what the question is asking you to figure out, is this statement, infected given tested positive. But we've already found this in the above question. We found that this was equal to the 57 patients who were actually infected and tested positive out of the 1,054 patients who tested positive, which gives us a solution of 0.054 or 5.4%. So if you're this doctor and you know that the person comes from the general population, you would definitely recommend that they take another test on this, because we've got this really, really small chance that they are actually infected given that they tested positive.